We are exploring the world of immersive production in DaVinci Resolve for the Apple Vision Pro. If you haven't already, please go watch the other videos in this series. In this video, we're going to concentrate on Fusion. We're going to create graphics, patch lenses, and look at how to integrate 2D footage. Our video needs an opening title. We will create 3D text and composite it with immersive footage. This is the shot that we have chosen. To create a Fusion composition, position the playhead over the clip and go to the Fusion page. When opening a 3D clip in the Fusion page, parallel pipelines are automatically created for each eye. The first step is not necessary, but it is helpful. I'd like to combine the left and the right eye to take advantage of Fusion's multi-layer functionality that was introduced in Resolve version 20. First, let's break these connections. A combiner node will allow us to combine the left and right eye into a single pipeline. Connect the left eye to the yellow input and the right eye to the green input. Then switch the combine mode to layers. We still need both media inputs, but we only need a single media output. Delete the second output. On the first output, reconfigure stereo eye to automatic. And finally, connect the output of the combiner to its input. You can tell it's successful because the layer dropdown on the right-hand viewer, which is currently set to show me media out 1, now has options to see the left and right eye. This step not only simplifies your node tree, but it's also critical for being able to monitor in 3D on the Vision Pro. When Stream to Vision OS is enabled, a third monitoring output becomes visible, just as it does when you have an Ultra Studio connected to your computer. Now that the left and the right eye are combined into layers, it's possible to send a stereo feed out to the Vision Pro by selecting a node and hitting the hotkey 3. Now I can see the output of this node in stereo in the Vision Pro. We will be using Resolve's 3D rendering system to create this graphic. There's some setup work to do. Let's add and connect a Merge 3D node, a Camera 3D node, a Renderer 3D node, and a Text 3D node. I'll load the Renderer node into the left-hand viewer. Currently, we can't see any text. There's two problems. First, we've not written anything. Let's call the video Mountain Adventure while it's a work in progress. Second, by default, both the text and camera are created with a coordinate of 0, 0, 0. They are on top of each other. Head to the Transform tab. I shall give the text a z-value of -10. It's time to style the text. Choose a font. Let's also reduce the line spacing to 0.6. Center everything vertically, and then we've got to make this text 3D. I'll give it an extrusion of 1 and a bevel depth of 0.01 and a bevel width of 0.01. It's really hard to see the shape that we've given the text as there's no lighting. Add a point light. Equipping the Merge 3D node in the left-hand viewer will help us to understand how these objects are positioned in relation to each other. I like to keep things nice and tidy, so rather than using the controls in the viewport, I'll manually enter X, Y, and Z properties. You can see the light is now above, slightly to the side, and slightly in front of the text. We still don't see its effects though, as lighting is not currently enabled in the Renderer node. Enable lighting in the Renderer. That's better. I'm going to leave it with the default material for now because there's plenty of other work to be doing. At the moment, our renderer node is producing a monoscopic rectilinear image. We can't composite that with our stereo immersive footage because that's in lens space. We need to reconfigure our 3D scene. We will start by deleting the Camera 3D node. In its place, add a spherical camera. At the moment, this camera is capturing 360 degrees. We only need 180 degrees. Switch the layout to VR 180, also known as half equirectangular. This is already looking much better. It's important that the configuration of the virtual cameras matches that of our real-world camera. Depending on the rig being used or the content being captured, a real-world camera might have eyes that look straight ahead or converge at a particular distance or feature shifted lenses. To match the immersive camera's configuration, select Parallel Mode. I'll configure an interaxial distance of 0.2. Now go to the Render node and choose to output both eyes as layers. We cannot composite it yet in this state. It's still in the wrong format. VR 180 is an equirectangular lat-long format. Our immersive image is in lens space. It's super easy to convert VR180 into lens space, add a pano map node, configure it to convert from VR180 to immersive. And this is so clever. Fusion is automatically using the ILPD data from the camera media to convert that VR180 image into the specific lens space of the camera that we shot this clip with. VR180 is a square format. The lens space image produced by the camera is not square. So we need to resize the image before we composite it back onto the original footage. It's okay to leave this set to auto, as it's copying the size of the underlying immersive media, which is 8160 by 7200. There's one last little thing to do. It's easy to forget. As our left and our right eyes are in separate layers, we need to configure every node we add to this pipeline to process all layers. That's done on the Settings tab in the Process Layers dropdown. Check this out though. Do you see all these extra layers that the renderer is producing? We don't need them. Before we configure the Panomap node, let's get rid of them by adding a special node called Layer Remover. Guess what that does? Remove everything except the left and right eye. If we need other layers later, we can add them back. Now in the Panomap node, I can happily set it to process all layers. Now our 3D rendering can be composited with the immersive image. A simple merge node is all that is needed. Don't forget to set it to process all layers too. I just want to take a moment to point out that Panomap has an additional input that can be used to import metadata when a specific ILPD is needed for the immersive conversion. For example, you could have a comp with clips from different cameras. Configuring the correct interaxial distance for your 3D cameras and placing your 3D objects in your scene is tricky because it needs to make sense once composited with your immersive footage. There's two tools that can help you to nail this. One, get your Vision Pro out and stream from Resolve. Here's option 2. Resolve has a node for creating anaglyphs. We'll set it up by connecting the Media Out 1 output to both of its inputs. Before polarized glass, active glasses, or VR headsets, a lot of 3D movies were created by projecting red and blue images and giving the audience colored glasses. For us, the real advantage of this tool is that it allows you to see the parallax of your 3D elements. That's how far apart they are in the left and right eye, and how that compares to the parallax in the rest of the scene. In this instance, I will ask myself, where do I want the text to feel like it is within the scene? Do I want it to feel far, close, or somewhere in the middle? Well, when I've decided, I need my text to have the same parallax as other objects in that part of the scene. Parallax is affected by both object distance and the interaxial distance of the virtual camera. Both need to be configured carefully to match the real-life camera used to shoot the background plate. In this instance, I can change the apparent depth of the text simply by moving it backwards and forwards until I see the correct parallax in the scene. Moving forward, I want this text to appear transparent and to refract the scene that's behind it. Fusion's 3D engine does not feature ray tracing, but we can fake it using some 2D tricks. First, temporarily disable the merge node that's compositing our graphics onto the immersive plate. We will create a parallel pipeline. Add an edge detect node. Adjust the settings so that it captures the details in the text. Make sure Process All Layers is turned on. Then add a Displace node to our immersive pipeline. Again, make sure Process All Layers is turned on. Connect the Edge Detect node to the foreground input of the Displace node. That's looking pretty cool, but it's a bit blobby. We can use the 3D render itself as an effect mask to give this displacement effect sharp edges. To do that, make sure you reference the 3D render before the Edge Detect node. Check that out. You can refine the effect by playing with the Edge Detect settings. Our image only contains the Displace effect currently. I will enable the Merge node that composites the render on top, but I shall change it to Screen mode and play with the blend value to achieve a transparent effect. We can make a couple of quick improvements. For example, I can make the text feel more like glass by increasing its brightness. To do that, I will add a color corrector node. Use the 3D render again as an effects mask, and then increase gamma and contrast to taste. And of course, don't forget to enable process all layers. There's one last thing I'm going to demonstrate. I want the text to have some movement. I'm going to animate two properties. First, the tracking of the text. I'll have the gaps between the letters start large and shrink as the shot progresses. Second, by adding a follower modifier to the text, I can have each letter rotate individually. I'll add a delay of 10 frames between each letter animating, and then go to the Transform tab and add an animation to the Y rotation. My graphic now looks something like this. There is, of course, more work we could do on this title, but we hope that this example has provided inspiration and shown you how to start integrating your own 3D assets with immersive footage. You've no doubt noticed that the Ursa Cine Immersive's field of view is so wide that the camera can see itself. The left eye can see the right lens and the right eye can see the left lens. We won't leave those lenses visible in the final render. The simplest method for removing them is to mask them out, and that's done in the color page. Enable the edge blend controls in the viewer. It's worth opening the 3D tab too because there are settings here that affect the edge blend. For example, at the moment, this link icon is enabled. That means the left and right eye will both use the same mask. With the controls in the viewer, you can create a custom mask that removes the lenses. You can delete or add points or move existing points around. To get rid of the lenses, I'll just remove a bunch of points to give the mask a flat side. As you can only see one lens in each eye, you might be tempted to create a different mask for each eye, but that can create distracting stereo issues. So I will make the mask symmetrical so that each eye can use the exact same mask. By the way, once you've built a mask that you like, you can save it. That's done in the 3D tab from the triple dot menu. Remember, we are in lens space currently. This mask, when unwrapped in the Vision Pro headset, looks like this. Do you see the distinctive shape where we have masked around the lens? That can be distracting. You can lessen its impact by feathering the mask. You can also change the mask's shape. For example, a completely circular mask that removes the lenses looks super neat. However, all of those solutions lose precious image. Here's another idea. Instead of removing the lenses, you can patch them. But be warned, this method is more involved and won't work on every shot. What we can do is use the left eye to patch the lens in the right eye and the right eye to patch the lens in the left eye. Load the clip into Fusion. I'll start by creating a rectangular mask for the patch. It only needs to cover the lens on the edge of the frame. Let's give it a soft edge and rename the node so we can keep track. This is the left mask. Duplicate it. This is the right mask. And switch the mask to the other side. Now we can add merge nodes to the left and right eye pipelines. Connect the right eye to the foreground input of the merge node in the left eye pipeline. Now we can connect the left eye to the foreground input of the merge node in the right eye pipeline. I can connect the left mask to the effect mask input of the merge node of the left eye pipeline. I can connect the right mask to the effect mask input on the right eye pipeline. By monitoring the left eye and right eye, you can see what we've done. Patched that tiny portion of the image where the lens was with the other lens. There's two problems that you will encounter with this method. First, because of the separation between the lenses, there will be parallax. Each eye will have a slightly different perspective of the scene. For very distant objects, the parallax is negligible. For objects or people that are close to camera, displacement is evident, especially when that person or object straddles the patch. You can mitigate that issue by using the transform controls in the merge node to shift the patch. When the patch contains both far and near objects, shifting the patch to fix near objects will break the alignment of far objects. The best case scenario is when the patch contains only distant objects that do not require any adjustment. The worst case scenario is a mix of both far, near, and moving objects. Here's the second problem. Because the left and right eye are seeing the exact same thing in that patch, there won't be any depth. Again, the best case scenario is that the patch only contains far objects at or close to the camera's infinity. Far objects have no parallax, so in that instance, your patch would be invisible. If your patch contains a consistent mix of intermediate distance objects, you can reintroduce the correct amount of parallax by once again using the transform controls in the merge node. In our edit, most of the shots feature distant or intermediate distance objects at the far left and far right of frame, meaning it was easy to patch the lenses invisibly or near invisibly using this simple technique. There's a small number of shots where the talent enters the frame from one side or the other. However, they move through the patch quickly and often at the beginning of a shot when the viewer won't be looking at the frame edge. So that means the audience would never see the parallax error. But still, they get the benefit of a wider field of view when they do explore the frame later in the shot. The vast majority of the shots in our edit will use this technique to clean up the lenses. To reiterate, the portion of the image that we are manipulating is on the far extremity of your field of view. For most people, this will only ever be in their peripheral vision. So make it look good within reason, but you don't need to sweat the details. Cloning out the lens gives your audience more field of view, and for us is much less distracting than having a weird mask shape on your image. In some shots that feature lots of movement, we chose to use edge blend to remove the lenses, like in the helicopter interior shot. Perhaps it's possible to use a combination of depth map and a displacement node to automate the process of fixing these parallax issues. That's a great topic to investigate in the future. Or perhaps AI-based tools will be developed in the future to automate lens paintouts. In the meantime, it's a super easy technique for using on wide shots of a distant landscape because there's no parallax issues with far objects. On shots that feature movement like our helicopter scene or super close objects like this indoor shot, it might be easier to just use a tighter edge blend in the color page. The final example that we will demonstrate is the conversion of 2D footage to 3D for incorporation into your immersive video. A lot of people want to know how they can film close-ups in immersive. With Blackmagic's current camera, that's not possible. You could build a stereo beam splitter rig using a Pixis 12K or a similar camera, but that's expensive and very complex. An alternative solution is to shoot 2D material and convert it in post to 3D. It's never going to be as good as shooting with a stereo camera, but for projects with small budgets, it could bridge the gap. We've chosen to shoot with the Pixis 6K. The 12K is an even better choice, but we didn't have access to it at the time. Of course, legacy media or highly stylized footage can be incorporated with immersive videos, but if you want your 2D to match visually with your immersive footage, among other things, resolution is important. Typically, a 2D plate won't be composited at the full width of the immersive container, but even when shrunk down, 6K should be your minimum acquisition resolution. We are pairing the Pixis with D0 Films Arles primes. They are clean but characterful at the same time. They hit the sweet spot. An overly vintage lens would create problems for the post-process as it tries to recognize physical objects in the scene and create depth maps. On the other hand, an overly clean lens is great for the technical process, but then we're missing out on that character. The effect of depth comes from each eye seeing a slightly different image. The difference in position of an object in each eye is called parallax. Objects have different parallax or are further apart or closer together depending on how far away from the observer that they are. The first part of the stereo conversion process is to use a tool like DaVinci Resolve's depth map to sense objects and work out how far away they are. That depth map is then used to displace the source image so that each eye has the appropriate amount of parallax. Fusion can actually do this part, and it can do it pretty well. Using depth map to displace the source image creates a problem though. It creates gaps in the image where the background needs to be painted back in. That process is often called stereo in-painting. DaVinci Resolve can't automate this process currently. There's a whole bunch of clever developers that are using AI to automate this process of stereo in-painting. I'm going to demonstrate one of those tools that is currently under development. Simply feed it your 2D shot. There are options you can configure, and it will then produce a 3D image in a format of your choice. I have chosen separate files for the left and right eye. I'll put details about the tool that I'm using down in the description. Please note, this kind of automated 3D conversion is a relatively new process. Results with the current tools can vary. Some shots will fare better than others. The best results are still achieved by converting manually by hand, but I'm sure that we're going to see a lot of growth in this field. Here are the two files, one for each eye. These need to be composited in Resolve. I will create a new Fusion composition, import my left and right eye files. As demonstrated previously, I will use a combiner node to combine them into a single multi-layer pipeline that can be connected directly to the existing media out node. Finally, so I can check that I'm doing everything correctly, I will add an anaglyph node after the media out node. Check that out. You can see that our 2D to 3D conversion has done what it was meant to. There's clearly parallax between the eyes, and the amount of parallax changes depending on how far away the object is. Awesome. There's two problems. One, the camera's field of view doesn't even come close to 180 degrees, but by default, the image is being expanded to fill your entire field of view in the headset. That's going to feel kind of uncomfortable. Two, our 2D images are rectilinear. They've been comped straight into lens space without any conversion. As a result, when these are unwrapped in the headset, they will appear distorted. Both problems can be fixed with a single tool, Immersive Patcher. Previously, we have demonstrated how to use it for paintouts. In this instance, we shall use it for the rectilinear to lens space conversion. Before we add the Immersive Patcher tool to our flow, we need to prepare the image. We're going to be using the Immersive Patcher in its distort mode. In that mode, it expects the image to be the same resolution as immersive footage and to have a non-square pixel aspect ratio. First, I'll add a letterbox node. Don't forget to set it to process all layers. And then use it to expand the image to fit 7200 by 7200. This tool preserves the source image's aspect ratio by adding letterboxing or pillar boxing. Then we will add a resize node, and as always, set it to process all layers. And use it for the final stage of this process, to stretch the image to 8160 by 7200. That will adjust the pixel aspect ratio by the correct amount. Now we can add the Immersive Patcher tool. Leave it in distort mode, but don't forget to set it to process all layers. It's as simple as that. The image now looks distorted when monitoring in Fusion, but remember, when it's unwrapped in the headset, it will look correct. You can change how large the footage appears in the headset by changing the angle of view property on the Immersive Patcher node. Finally, if you're feeling adventurous, you can add a black frame that floats in front of the footage. For it to appear 3D, you'll need to offset that frame in the left and right eye, but it's worth the effort as it further helps to sell the illusion of the image having depth. The quality of the finished product is dependent on the quality of the 3D conversion. As mentioned, automated tools for creating spatial conversions is still a growing field, but we think these tools will continue to grow, so we're happy to demonstrate the compositing techniques in Fusion so that you're ready once the tools are there. Finally, what if you want to convert a simple 2D image to be viewed as part of your immersive video? You can use the exact same technique with the Immersive Patcher, just without separate left and right eyes. There's so much more that can be done to your immersive footage in Fusion. We really hope that this has whet your appetite and inspired you. It's incredible that Resolve has all the tools you need to edit and composite immersive footage. In the next video in this series, we will focus on spatial audio. If you found this video helpful, please give it a like, share it with a colleague, and subscribe so you don't miss out on our next video. Thanks for watching.